Hello everyone. Today is the 63rd day of Leetcode 75 challenge. Let's begin with the 63rd question. Question 62, unique paths. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given two integers, right? M and N, and you need to compute the number of unique paths a robot can take from top left corner. Suppose if this is the given grid, suppose m cross n. So 0 comma 0 is this part, right? From here to the bottom right corner, m cross n minus 1. So this is the m cross m minus 1 n minus 1, okay, which is an m cross n grid. Now the robot can only move to the right, which means this direction, or from here this direction, or down at any point in time, okay. Now your goal is to return the total number of unique paths possible to reach the bottom right corner from the top left corner. If either m or n is 1, then there is only one possible path, which is a straight line. Basically, if the m cross n grid is this way or this way, the output will only be one, definitely, because it's not possible, right? You can assume that m value and n value is within the range 1 to 100, okay. The number of unique paths will always be less than or equals to 2 into 10 to the power 9, so you can safely return the result as an integer, okay. So this is also given to us. So basically what problem is asking is that we will be given a grid, okay. Suppose this is a m cross n grid. You will start from here, the robot, and he has to reach here, okay. So for that, either the robot can go to right side, then left side. This is one of the way. Either can go down and come here. Either can go down, then come down, go to the right, then come here, then go to the right. So we have to find all these possible ways for this robot to reach to this particular point, okay, and we have to return it. Now the constraints for these problems are m value and n value is between 1 to 100, okay. So I hope you understood the problem explanation. Now let's move to the next slide. Now let's understand the input output explanation. So since here it is given us m and n is 7, right? So if this is your grid, okay, if this is the grid given to you and you're starting from here, okay, the output is 28. That means there are 28 ways to reach here, okay. And so we'll try to figure out some of the ways, because figuring out 28 ways will be a lot of time. So one way could be this, okay. One way could be you can go straight, then from here you can come down, okay. One way could you came here, then you from here you came up to this line and you came here, okay. Three ways, let's try again, okay. You came from here to here, then here, then here, then straight to till here, okay. Four, another way could be, suppose from here you came here, then here, and here, well, that means down, then to the right, okay. Or so you can take this way, right till here, then down, then right, then down, then right. So here we have already found how many ways? 1, 2, 3, 4, 5, 6, 7, 6 to 7 ways we have just seen here already, right? Similarly, there are 28 ways to do this, okay, by going right or down. Only two ways to go, okay. So I hope you understood our input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. So let's start by understanding the goal. We are given two integers m cross m and n, okay, and our task is to compute the total number of unique paths a robot can take to move from top left corner to the bottom right corner on an m cross n grid. That's simple understanding. The constraint is that a robot can only move right or down at any point, this way or this way. So for example, for a 3 cross 3 grid, there are 6 unique paths to reach the destination. This is one of the example. If you take a 3 cross 3 grid, there are 6 possible ways. So please try it out if you have any doubt, okay. Now please try to understand, whenever we are asked to figure out, find all possible ways, okay, or find find all possible ways, then find the max or minimum, okay. Or directly if it is said, find the maximum from all opportunities or possible scenarios. So when we have to go for all the possible scenarios for a particular solution, there is always a 101% chance or 99% chance, I would say, that it is a recursion question. Okay. So when a question boils down to a recursion one, there are one scenario that the recursion can work it out, or we have to go to the DP, which is basically dynamic programming. Okay. Before going to DP, we try to build up the recursion solution. And for this particular problem, the recursion is the brute force. Okay. Because the brute force approach would explore all possible right and down combinations leading to many repeated calculations, right? And that repeated calculation time complexity will be 2 to the power m cross n. Okay. Why m cross n? Because the grid size is m cross m. Okay. And for each cell, you can either go to the right or you can go to the down, right? There is a 2, and since the size of the grid is m cross n, so you will explore m cross n possibilities. That is where the time complexity that is where the time complexity comes out to be 2 to the power m cross n. So we have to reduce the time complexity, and how we will do that? We will try to use dynamic programming. Okay. But before going to dynamic programming, we will build up the recursion solution. Then we will try to convert it to a DP. Okay. So now let's try to visualize the process. Now, in our intuition buildup, I would say we know that for this particular scenario, we have 6 output, 6 as the answer. Okay, we know that for sure. Now, okay, so before building up the intuition, I want to clear something out here. Since we are given, we have to start from 0 comma 0 and have to go till m minus 1 comma n minus 1. Okay, and for that we can go to the right and we can go to the down. If we start from the 0 comma 0, what if, let me draw this here. Okay, if you start from here, so what it will be? It will be starting from m minus 1 to n from comma n minus 1 to 0 comma 0. Now, since from here you cannot go to the right or you cannot go to the down, what will happen? If you can think of it, it's great. Otherwise, we'll go up and we'll go left. Okay, we will just reverse the scenario as we have reversed our starting and ending position. Okay, so keep that in mind. We will be going up and left. Okay, so let's try to build up the intuition. Okay, so if you are starting from we are starting from here, what, since it's a 3 cross 3 shell, so we will be starting from 2 cross 2, right? M minus 1 n minus 1, right? Okay, now before proceeding, okay, before proceeding, if suppose we are taking I comma j, definitely since it's a 2D array, if I is becomes less than 0 or j becomes less than 0, what should happen? Suppose you are standing somewhere here and from here I is the row. Suppose let's take I as the row. Okay, so if row is coming out, will you calculate out of bound things? No, right? So for that we will return what? 0. Okay, if I is 0 or j is 0, if either of the scenario becomes true, suppose I is 0, suppose I is 0, suppose let's take as uh, nums or whatever, right? N equals to I comma ij. Okay, if I is 0, that means you are in this particular row. Okay, and if I is 0, suppose I is 0 and j is suppose 1. Okay, which means that you are standing here, correct? So what does it mean is that if you're standing here, right, and you started from here, and suppose you came this way, then this way, then you're standing here, right? That means that there is only one possible way, that you will go here. So this complete path will make one way to reach from n minus, from this position, ending position, to the initial position, correct? So that is why you will return 1. This is our base case. If suppose j is 0, suppose this is something 1 and so this is something 0. Okay, and that means that you are standing here. Suppose you came this way only itself. Okay, okay, I took 1 as row. Okay, so let's, so you started this way and you came here, you're standing here, right? So that means you're not going there, neither you can go down, right? You can only go up. So we'll come this way, so this becomes a complete one way. So that is why whenever we reach the last row or the last column, we directly return 1. Okay, So I hope you understood this both of the base cases. Now let's understand the recursion tree. Okay, so let's try with the recursion. Okay, suppose this goes for the left and this goes for the up, right? Because from here you have two options. So if you go to the up, what will happen? The row will reduce, it will become this way, correct? Again, from here you have two options. L means left, U means up. Okay, so what you will do? This becomes 0, this becomes 2, this remains 2. Not becomes, it remains 2. Okay, then from here you have two options, up or left. If you go to the up part, okay, it will become -1 comma 2. Fine. So from here we knew that if anything is, if you remember the base case, if I is less than 0 or j is less than 0, just return 0. So this particular scenario will return 0. Okay, then from here you will come to this part, the left part. The left part, what will happen? This will remain 0, but this will become 1. Now again you have two options, correct? And here it will become negative again. This will remain 1. So it will return 0 definitely. And from here you will come here. What will happen? This becomes 0, right? Okay, great. Now I'm not returning anything right now. Okay, I will return it for you. Here what will happen? If you take left, it will remain 1 and it will become 1 comma 1 definitely. And what will happen to this? This will become 2 comma 1. Okay, now since this is a negative scenario, this will return 0. Okay, and suppose if this also goes to the left and right, it both will return 0. So this will return 0, right? So it has 0 right now. Fine. But we knew that if I is 0 or j is 0, we used to return what? We used to return 1, right? So here we can see I is 0. So what it will return? It will return 1. So this has 1 right now. Okay, great. If you want to explore this part here also, if you can see, if you are coming from 0 comma 0, then if you go to 0 comma 1, which is this, right? Then if you go to 0 comma 2, which is this, okay, this is one of the way. Then this will take 1 comma 2, this one, right? Then it will go to 2 comma 2, up or down, right? Whatever it is. So if you can take the scenarios this way, right? So if you look at, if you started from 2 comma 2 here, then you came to 1 comma 2, which is this, then you came to 0 comma 2, which is this, then you came to 0 comma 1, which is this, then you came to 0 comma 0. So this is the one path. So you return 1, right? Correct. Great. Now, so this path returns 1. Okay. Now, if you have taken this path, let's explore this path also now. I will clear this up. I hope you understood this one. Okay. Let's take this path. Okay. It will go left, it will go up. So if it goes up, this becomes 0 comma 1 and two options again. This becomes negative 1 comma 1 and this becomes 0 comma 0, right? Now I will clean this up now. Now suppose if you started from 2 comma 2, you're standing here, then you came to 1 comma 2, right? Then you come to 1 comma 1, right? Then you came to 0 comma 1, definitely. Okay, and from here you went to 0 comma 0. Okay, this makes one path from this part, right? Because this returns 0, but this returns 1 because it is at 0 comma 0. If I is 0 or j is 0 at the end, right, at the end here both are 0, so it will return 1. Okay, so this will uh, go back here with 1. Okay, and suppose if you go to the left from here, it's 1 comma 0, then you have two options, it becomes 0 comma 0 and it becomes 1 comma -1. Okay, so this 0 comma 0 returns 1. Now if you do go with this path will go from this 1 comma 1, 1 comma 1 you went to 1 comma 0 here, and from here you went here, right? So it generated another path. So I hope you understood this recursion tree. Okay, now how will our recursion will look like? It will look like, since we're going up, so something function I minus 1 comma j, Okay, if you're going to the left, it is like I, it's like I, comma j minus 1, right? Now, since we have to calculate the total sum, not the min or max, so what we will do? We will just have a function, suppose ways at ith comma jth index. Total number of ways are, you take this up and you plus it with left. So this is your complete solution for the particular recursion. Okay. So I hope you understood the visualization process. Let's move to the next slide. Now, how we can simulate this process? Okay, I have already explained you the base cases. I is less than 0, or if j is less than 0. If I is equals to 0 or j is equals to 0, return 0, return 1. Okay. Now, since it's a DP, since we will be converting into a DP, right? So we will create a DP of size n cross m cross n. I will show that to you later. So for a DP check, if I comma j, suppose if you have taken I comma j, if it is not equals to minus 1, so we return the DP of I j. This means that, okay, since DP of ij is not minus 1, that means for this particular index, or this particular, I comma j, we already have the solution to it, so we won't be calculating it again. So this reduces our time complexity actually. Okay. Otherwise, what we can do is that we can split up, like up equals to something like, uh, we call the function here with I minus 1 and j, and suppose left also similar way, solve I j minus 1, and at dp of ij we will try to store the up plus left. Okay, and after that we will return the dp of ij. Okay, so this is how we can simulate it. So let's move to the next slide. What we figured out? We figured out that dynamic programming help us to break the problem into smaller sub problems and reuse their results. The 2D DB table stores the number of paths to each cell, avoiding repeated calculations, right? Because here we are going to have 2D DP. Why 2D DP? How that we figured out? Because here I and j, both two, we could say, parameters of functions are changing simultaneously. That is why. Solving the problem recursively from the bottom right corner avoids recomputing values by memoization. So it reduces our time complexity from m cross n to, I will let you know in the next slides. Okay. So I hope you understood the intuition. Now let's move to the next slide. Now since you got the intuition of the problem, let's look into the approach how we're gonna solve it. So first, in the main function which is given to us, m cross n, we created 2D DP list, and how that is created in Python. So it will take DP of DP will be equals to minus 1 for in range, okay, n, again for in range, because why n there not m, because it's m cross n DP. Okay, this is n, and this becomes for as in range m. So how the DP will be created? M is the number of rows, right? So how the DP is created? N is the column. So this is the inner part. Okay. Suppose n is 3, so it will create like this. And m is supposed 2, so it will be added this way. So this will get filled for m, this will get filled for n. Okay. So this is how DP will be created. Now, second part, the edge cases which we will write in our solve function, which the recursion function which we will be writing. Okay. In that, it's simple. As I already explained, we will write these base cases, and these are base case where the robot has only one way to reach current cell, either fully right or fully down. If I is 0, fully right, in our case left. If j is 0, fully down, or in our case fully up. Okay, that which I explained already. Now at step 3 we do the memoization. This is the basic DP case. Okay, if true, return stored values already. Otherwise we have these computable functions, and we store it in the DP, and we return the DP at the end. Okay, this ensures each subproblem is solved only once, builds a solution using the overlapping subproblems. At finally at step 4, when this solve function is totally calculated in the base function, we will return our output. Suppose this is the main function which is given to us. Here we will just return the function solve, which has I and j with it, and the DP, because this function here will finally give a solution to us, right? So here we will return it. So I hope you understood the approach explanation. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. So if here you can see that we have initialized the 2D DP, and we have called the function here. Now these are the base cases. If out of bound is there, return 0. If we are standing at either row or final column, return the 1. If the particular value is already calculated, return that value itself. Otherwise, do the up and left calculation using recursion, store it in that particular index, and return it. Okay, it's that simple. Now the time complexity for this comes out to be n cross n, and space complexity comes out to be m cross n. Why space complexity is m cross n? It's pretty definitively here seen here, since we are creating a DP of size m rows and n columns. That's all. That is the reason for being a m cross n space complexity. Now, why time complexity is m cross n? Because we are traversing a grid. Very simple. Because you're traversing a m cross n grid. And to traverse m cross n grid and to see all possible paths, we required m cross n time complexity. But it is much lesser than 2 to the power m cross n time complexity. Okay. So I hope you understood the code explanation. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Now, for the dry run of this will take a lot of time. So let's take instead of this, let's take a 3 cross 3 DP grid itself. Okay, if we take 3 cross 3 drive or grid, we start from here. Ending is here 0 1 2 0 1 2. I have also brought down the code for us for better understanding of the dry run. Okay, so let's start. I will just try to give a dry run for particular scenarios itself only. Let this be the 2 cross m cross and DP. 0 1 2 0 1 2. This is the DP. Okay, let's start. We start here. Right now we have 2 comma 2 with us. Okay, we're standing here. So all these conditions are falsified right now. Okay, so we'll go up. In this scenario we are trying to go up. Okay, so we came here. Again this function is called. Again base cases are checked. So again up function is called. Fine, we're here. Again for this up function these base cases are checked. Now here we can see that I is not less than 0 neither j, but here I is equals to 0, right? So from here directly we return 1. Okay, so if you are only going up, we are having 1. Now for the left we will call the function, right? Now we will call for j minus 1. So from here j minus 1 will come this side. Again these base cases will be checked. Okay, again this up function will be called. Since we cannot go up, so it will return 0. Okay, so here written 0 and here it was written 1. Now again the left function will be called from here, so we'll reach this particular scenario. Okay, we will see that I is also 0, j is also 0, so this will also return 1. Okay, now we'll come in this part. Now dp of I of j. So for dp of I comma j, right, or basically 0 comma 0, you will be having 1, right? So we'll replace this. So we will replace this with 1. Great. Now we'll move back, right? Because this is done. So function, this will be returned, right? This will return to its next value to this part, correct? So this has only one, right? Which means that 0 comma 0 in this scenario, I remember if this was 0 and this was, and this, I mean, we're getting back 1, right? So 0 plus 1 means that left plus right up value we are getting, right, back. So it becomes 1 again, right? So this becomes 1. Okay. But if you remember, this particular is one which we got from going only in the upward direction, correct? That is why for this particular scenario, the value will be 1 here again. So this is done. Okay. Now suppose after that you came back again to this particular part, or you could say you came back to 1 comma 2. Okay. Now from 1 comma 2 you already explored up, right? And you got the value. Now you have to go to the left. If you go to the left, let me draw the, okay, I'll clear this up. Great. So from here you will call this left function and you will come here. Okay. So now it's what? It's 1 comma 1. Okay. So standing here, then again these values will be checked, then you will come back here and you will move to 1 up ahead again. Okay. Now as soon as you go to up again, because this up function is called, you will see that it does not fulfill the condition. It does fulfill the condition, right? So we will return 1 from here. So we will write 1 is returned from 0 comma 1. Okay. Great. After that you will come back here and you will go to the left. Left function will be called. Left function says that you are standing at 1 comma 0. Okay. And since j is 0, for this you will return 1, right? So this particular scenario will return 1 and this will also return 1. Okay. So when you come in dp of I of j, up plus left. Now this is done. Okay. So this will return 1, right? So this will be get filled with 1. Okay. Because as we standing at that, if you remember, uh, for 0 comma 1 we already had 1, and for 1 comma 0 we returned 1, right now. Then after that what happens is that when you go back, this is done, right? So you come back here. So when you come back here, this is 1 comma 1, right? So for that what will happen, up plus left will happen, which is 1 plus 1, which will become 2, right? So here this will become 2, coming from left, coming from up. Okay. I hope you are getting it, because since it is a recursion and a DP, so you should be having a kind of a knowledge of how the dry run goes on. Okay. So similarly, I'm skipping the part here because drawing the complete DP will take a lot of time, but I will make an easy approach for you. Now, if you come back, please focus on the DP now, how DP will work. Okay. Now, what will happen when you will come back, since you started from here, 2 plus 1 will become 3, right? Then again, you will start from here and you will go to left. Then again, you will go to left, right? And here you will get, or you will be returned with 1. Okay. Then when you will come back from here, you have up, left plus up, it will be 3. Okay. Then from here you will come back, up plus left, you will get 6. Okay. And at the end, since we are returning dp of I of j, so dp of m minus 1 n minus 1 will be returned. Finally we will get 6 as the answer. So yeah, I reduced, I didn't did the complete dry run, but this is how the dp will work upon. Okay. So I hope you understood the dry run. But if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach, and the code. And also, if you are not as much clear in recursion and DP, please go and understand those concepts also. Do a dry run by yourself on 2 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since you're familiar with the problem and solution, let's move to the lead code and code the solution. Okay, so let's start by defining the DP array first. N is already given to us for in range M. Okay, then we will just call or return the self dot solve function, and we will have I, or you could say m minus 1, n minus 1, and the dp. That's all. Now we will create the main recursion function. This is solve self I comma j comma dp. If I is less than 0 or j is less than 0, we returned 0, right? If I is equals to 0 or j is itself equals to 0, we just return 1. Otherwise, if dp of I comma j, if this is not equals to minus 1, what will happen? We will return dp of I comma j. Okay. Otherwise, we will calculate up, which is dp, which will basically solve of I minus 1 comma j comma dp, and left, which is solve I comma j minus 1 and dp. And after that, we'll just add the sum here, dp of I, dp of j equals to up plus left, and we will return dp of I comma j. Okay, right. Now let's try to submit for the sample test cases. Okay, so there is an error with the bracket, I guess. Yeah, let's try again. Okay, let's try submitting again. Now let's finally submit all the test cases. So we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.